Hello everybody, welcome back. Today we're going to be doing more electrolysis. First and foremost, I tried a new power supply, which was... well, it works better than the other one I tried. You see, the first time I tried a new power supply, it made popping sounds, but this one actually worked. And then it shut off. Anyway, today we're electrolyzing something they use to melt ice. Now basically, this substance comes with wonderful additives, which are this blue substance. It's either additives or like something else. I know this says additives in there. I have no clue what the additives would be, but I'm not sure what the blue stuff is, but I know that something in here is sodium chloride and the other thing is calcium chloride. So I tried separating out the larger objects by just cutting a hole in the bag, which was too small for them to fit through. I then separated undissolved crystals by decanting this blue liquid. This blue liquid would have hopefully made it through the video. However, it was very rainy, and so my inert graphite slab decided to become very slippery. And also I used a beaker that was way too small. You see, the amount of things that fell off this graphite slab today was quite a lot. In fact, we had a casualty from this, but you'll have to watch to find out what happened. While the blue liquid did electrolyze, I did not notice it at the time, but I caught it on the video. I would have tried to recover some of the liquid had I realized it was actually electrolyzing. I mean, we could always try it again, right? Anyway, I proceeded by dissolving the other stuff in the water, the stuff that didn't dissolve, and using a larger beaker because, well, that was the problem I was having. They solved quite a few issues, except for the rain, and in fact, the rain got even worse, and everything gets even more coated in water. Probably the coolest part of electrolysis is all the bubbles that form. And these bubbles are, well, they're supposed to be chlorine gas and hydrogen. However, I have not noticed it being yellow, and I'm kind of confused. Of course, it probably has something to do with the current density. What I mean is that at different current densities you get different products. It favors different things. I think at a higher current density it actually favors the oxygen production over chlorine. And for solid products or liquid products, at the lower voltages you get the hypochlorites, and then at the high voltages you get hydroxides usually, I think. Usually I use a piece of iron at the anode in order to prevent the formation of hypochlorites and hypochlorites because it destroys them. I'm pretty sure this works by them basically oxidizing the metal. And this also works with nickel and copper too. I have read about another metal that can react with the hypochlorites and hypochlorites, and I don't remember what it is. So the products of this reaction, as we discussed, are hydrogen and chlorine gas. But also, we have calcium chloride present. Calcium is a +2 charge. This means it can hold 2 ions if they have a 1 charge. Now if we have chloride ions present, then it would appear that the chloride ions can form calcium hypochlorite. Calcium hypochlorite is a powder, and it's used for bleaching. As far as the industrial production of it is concerned, I don't think they produce very much because it doesn't have a very long shelf life, from what I understand. Speaking of quite a long shelf life, that battery there was, it was sticky. Anyway, I had this wonderful idea to use this UV light, because I've heard that if you use a UV light on hydrogen chlorine, you get hydrogen chloride, which is a very fun chemical. Its most notable use is in hydrochloric acid. It's basically dissolved into water. Now, the industrial production for hydrogen chloride involves a hydrogen chloride furnace. This machine usually has a graphite inside, as graphite's able to withstand high temperatures and doesn't react with the hydrogen chloride. And it works by burning hydrogen in the presence of chlorine, which basically gives hydrogen chloride. So after my attempt had failed to use UV light to produce hydrogen chloride, I decided to make some kind of very strange collection apparatus. Now, I've redesigned the sense, as prior to now the design was very poorly designed. The new design actually has it go straight into the bottle instead of going at a funny angle, where it could get strapped in the PVC pipe. And in the future, this design will be used much more extensively. In fact, I will use this design with the electrodes on the inside and have it sealed to a container. This will allow us to collect 100% of the gases. Now, when I said it was kind of wet outside, it was quite wet outside. This is the cables, and they are rusting. This is probably a combination of other previous experiments where they accidentally got dipped in there, but also it was raining. And then we had a very close call where the glass almost decided to jump off. So I had to put my phone down on the wet graphite, which some of the liquids have crystallized on the back of the phone case. But I can guarantee you that it's perfectly fine. And then I guess finally the glassware just had enough. It was like, no, I'm done. It became one with the rocks, and also prevented me from recovering any liquid or solids or doing anything fun with the liquid. But we still have this wonderful bottle of gas. Before I knocked the bottle off, I had sealed the valve on it. This prevented any of the electrolyte solution from getting inside, fortunately. As if we had anything basic in there, it could probably cause some issues. Whenever anything breaks, you should put on some gloves, make sure you're wearing some heavy rubber boots, and you should just be wearing those anyway, honestly. There's no reason not to. And also, it's recommended that if you're doing anything where it could potentially break, you should probably wear goggles. Although I wasn't. See, I tend to wear goggles whenever there's gases involved that could potentially be absorbed into liquids, or if there's anything boiled, but I don't boil anything. You know, it's quite surprising how quickly one of these pieces of glass can break the second it hits something very hard, but it's also not surprising at all. Just like, you don't expect it. When you see it in many pieces, it's quite interesting, because you're just used to seeing it in one piece, but when it's a million, it's just different. With all said and done, I hooked up one of the UV lights to the 5-volt supply we use for the electrolysis. This results in maximum power, and also, quite interestingly enough, some of the water droplets in there, because the bottle was not dry, had become this strange white stuff. And what this means is that the trace quantities of chlorine and hydrogen that we'd managed to store in there became hydrogen chloride, and then were immediately absorbed into the water that was residual on the outside of the, well, actually on the inside of the bottle. Basically, this means we made tiny droplets of hydrochloric acid. Or it could just mean nothing at all, and I could just be dreaming. But in the future, I do plan on attempting this again, but with better results. And of course, what is most interesting is how this looks. It looks like something dried on there. And also, it smelled kind of interesting too when I did this. When I was doing this, it kind of was warm. The smell was warm. I don't know how to explain it. It's like warm plastic.